Want to crack Amazon SDE/backend interviews? This video goes beyond basic questions and dives into real-world, tricky interview questions with deep explanations exactly how Amazon evaluates candidates. How does HashMap work internally? When you insert a key-value pair into a HashMap, Java doesn't store it randomly. It first calculates a hash of the key using hashcode. That hash is then transformed into an array index using index equals n1 and hash. This works efficiently because the array size, n, is always a power of 2, allowing a fast bitwise operation instead of a costly modulo. Now, each index in that array is called a bucket. If multiple keys land in the same bucket, collision. Java handles it differently depending on the version. Before Java 8 linked list. Java 8 plus if collisions exceed 8 converted into a red-black tree. Why? Because linked list lookup is O, n, but tree lookup is O, log n. This is critical when attackers or poor hash distribution cause many collisions. What impresses interviewers is when you mention why 8 is chosen. It's a trade-off between memory overhead and performance. Trees are heavier, so we only use them when collisions become significant. Real-world insight. If you design poor hashcode, your HashMap performance can degrade badly, even today. Why a transactional is not working. This is a classic Spring trap. Spring uses proxies, AOP, to manage transactions. When a method is annotated with a transactional, Spring wraps it in a proxy that starts transaction before method, commits/rolls back after. But this breaks in cases like self-invocation. This .save data. The call bypasses proxy transaction not applied. Private methods. Spring proxies only public methods. Real-world fix. Move method to another service class. Or call through Spring Bean. Interview insight. They want to see if you understand how Spring works internally, not just annotations. Data consistency in microservices. In distributed systems, you cannot rely on ACID transactions across services. So instead, we use Saga pattern. Example. Order created. Payment processed. Inventory updated. If payment fails, we trigger a compensating transaction, cancel order. 2 types. Choreography services emit events. Orchestration central coordinator. Why not 2PC? Slow. Not scalable. Not fault tolerant. Real-world insight. Event-driven systems improve scalability but add complexity. SQS versus SNS, deep real usage. Think of it like this. SQS equals Q1 consumer processes message. SNS equals pub/sub multiple subscribers receive message. Real-world architecture. SNS publishes event multiple SQS queues subscribe. Example. Order placed. Email service gets message. Billing service gets message. Analytics service gets message. Why combine them? Decoupling. Scalability. Reliability. Failure handling. Dead letter queue, DLQ. Retry mechanism. Interview insight. They want architecture thinking, not just definitions. Thanks for watching. If you found this helpful, like, comment your doubts. Subscribe for more deep backend content.